Hi guys, welcome back. Today we are going to learn about right-angled trigonometry. We've got 4 success criteria, and the first one is to just recall trigonometric ratios. So first of all, you need to be able to label the triangle correctly. So in trigonometry, you'll be asked to find a side or an angle given some information. So if you're asked to find a side, you'll always be given one of the angles in the triangle, and the other angle will be a right angle triangle. So opposite the right angle is the side known as the hypotenuse. So the side that's opposite the right angle is known as the hypotenuse. The side that's opposite the angle, this side over here, that's known as the opposite. And the side that's in between the right angle and the angle is known as the adjacent. And we normally label these sides O, A, and H. So remember, the opposite, the side that's opposite, is opposite the angle that we're given. The adjacent is in between the angle and the right angle. And the hypotenuse is always the longest side, and it's always opposite the right angle. For trigonometry, you need to remember SOHCAHTOA, SOH, CAH, and TOA, because this tells us whether we are going to use sine, cos, or tan. So sine and then the angle is equal to the opposite divided by the hypotenuse. Cos and then the angle is equal to the adjacent divided by the hypotenuse. And tan and then the angle is equal to the opposite over the adjacent. We always use that symbol there to denote an angle that we don't know, and it's called theta. So now we've completed success criteria 1. So now we're going to move on to number 2, and this is to find missing sides using trigonometry. So we want to find the side labelled x, and we're given the angle that's 52 degrees and a side that's 9 centimetres. So the first thing we need to do is label the triangle. So that side is the hypotenuse because it's opposite the right angle. This side is the opposite because it's opposite the angle that we're given. And this side is the adjacent because it's in between the angle and the right angle. Now we think about SOHCAHTOA. So we're trying to find the opposite and we're given the adjacent. So O and A means we're going to use TOA. Now that means we're going to use tan. So tan theta is the opposite over the adjacent, and you've got to get them this way round. Always put them opposite over adjacent. So we write tan 52, because that's the angle, is equal to the opposite, which is x, over the adjacent, which is 9. So because 9's on the bottom of the fraction, we can times both sides by 9, and that means that x is equal to 9 times by tan 52. So if we type that into our calculator, 9 times by tan 52, we get 11.52. And remember, that's the length, so it's centimetres, and that's the 2 decimal places. For this example, again, we need to label up the sides. So the hypotenuse is opposite the right angle. The opposite is opposite the angle that we're given. And the adjacent is in between the angle and the right angle. So now we think about SOHCAHTOA. We're trying to find O, and we're given H. So it's O and H that we're looking at. That means we use SO, which means we use sin. So sin theta equals opposite over hypotenuse. So sine 30, use the angle that we're given, is equal to the opposite, which is x, divided by the hypotenuse, which is 11.2. because 11.2 is on the bottom of the fraction, I need to times both sides by 11.2. So I type into the calculator 11.2 times sine 30, which is 5.6 centimeters. So the side labelled x is 5.6 centimeters. Let's have a look at this example. So label up my sides. So that's H, that's O, and that's A. And then we think about SOHCAHTOA. So I'm given A and I'm trying to find H. So that's Ka, which means I'm going to use cos. So cos 46 equals 11.2 over x. Remember, it's A over H. Now, because x is on the bottom, what I need to do here is just swap around the cos 46 and the x. So if x is on the bottom of the fraction, we can just swap those round. That means that x equals 11.2 divided by cos 46. So if we type that into our calculator, x equals 16.12 centimeters. Here's a question for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So let's have a look at this question. First of all, label up your sides. Then think about SOHCAHTOA. Well, we've got the opposite and we're trying to find the hypotenuse. So we need to use SO. That means we're going to use sin. So I write sin 39 equals, now it's opposite over hypotenuse. So I've got to write 8 over x. And because x is on the bottom of the fraction, I need to swap those two round. So x equals 8 over sine 39. If I type that into my calculator, I get 12.71 centimeters. Here's some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So there's your green answers, there's your amber answers, and there's your red answers. So now we've completed success criteria 2, we're going to move on to number 3, and this is to find missing angles using trigonometry. So this time we need to find the angle inside the triangle when we're given 2 of the sides. So we do exactly the same thing as before. We label up the triangle. So that side is H, there's O, and there's A. And I'm given O and H, which means I'm going to use SO. So it's sine that I'm using, or sin. So because I'm not given the angle, I need to find the angle. I just write down sine x equals, and I need to get these the right way around, otherwise it won't be correct. It's opposite over hypotenuse, so that's 7 over 10. Now when I'm trying to find the angle, I need to do the inverse of sine, which is sine to the minus 1. So I'd get that on the calculator by doing shift and then sine. So I need to press shift and then sine on the calculator, and then I can type in the fraction 7 over 10. So if I type that into the calculator, shift sine and then do the fraction 7 over 10, I should get the answer 44.43 to 2 decimal places. So that's the size of the angle x. Again, in this question, label up the sides. So there's H, there's O, and there's A. Now I'm given O and A, so that's what I'm going to use. So I need to use TOA. So tan theta equals opposite over adjacent, which means tan x equals 3 over 8. Again, I need to do the inverse of tan, so that's the opposite of tan, so tan to the minus 1. So I press shift tan on the calculator to get tan to the minus 1, and then I type in the fraction 3 over 8. If I type that into the calculator and press equals, I should get 20.6. So x is 20.6 degrees to 1 decimal place. Here's a question for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So let's see what we should have done for this question. First of all, label up your triangle. There's H, there's O, and there's A. So I'm given O and A, which means I need to look at TOA. So that's tan theta equals opposite over adjacent, which means tan x equals 5 over 9. So I need to get tan to the minus 1, 5 over 9. So on my calculator, I press shift and then tan, and then 5 over 9 as a fraction. And I should get x equals 29.05 to 2 decimal places. Here's some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So there's your green answers, there's your amber answers, and there's your red answers. And now we've completed success criteria 3. So we're going to move on to number 4, and this is to apply to problem solving questions. So ABCD is a parallelogram, DC is 5 centimeters, and angle ADB is 36 degrees. So we want to calculate the length AD. We want to give our answer correct of 3 significant figures. So we know that angle there is 36 degrees because of alternate angles in parallel lines. And we want to draw these triangles out separately. So there's the triangle BDC, and we need to find that side there. So we label up the sides. We think about which one we need. So we need to find the adjacent, and we're given the opposite. So that's TOA. So I do tan 36 equals 5 over x, because x is on the bottom of the fraction. I need to swap around the tan 36 and the x. So x equals 5 over tan 36. So x is that number there. Then I look at my second triangle, and I want to find the length of AD. So that's that side there. So again, label up my sides. And I need to find H, and I'm given A. So that means I'm going to use K. So I use cos. So cos 36 equals 6.88 over AD. So I swap those rounds because the missing side is on the bottom. So AD equals 6.88 over cos 36, which means AD is 8.51 centimeters. Here's another question to have a go at. So we want to find the length of AE. So it's always a good idea to sketch the final triangle first to help you plan out which parts of the shape that you need to write out. So we're looking at that triangle there. So by working out the angle, I can find AE. So I need to find that angle at B. So if I look at this triangle first, DCB, I can work out the third side through Pythagoras' theorem. So the hypotenuse, that side there, is the square root of 136. I'm going to leave it as the square root of 136 for now. Then I can look at this triangle, DAB, and I can work out the length of AD through Pythagoras' theorem again. So AD is the square root of 55. Then, still looking at that triangle there, ADB, I need to work out the angle at B, so I can use trigonometry for that. So we use SAW. So the angle ABD is going to be 39.489 degrees. Then I can work out the other angle at B of this triangle here. So I use TOA. Which means angle CBD is 30.96 degrees. So that whole angle there, if I add those together, is 70.445 degrees. And now I can work out the length of AE using trigonometry. So I want to find the opposite, and I've got the hypotenuse. So that means I'm going to use SAW. So sine 70.45 is equal to AE over 9. So if I times by 9, that means the side AE is 8.48 centimeters long. Here's 2 questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. So let's go through both of these. So the green question first. If I work out BD first, that will help me. So I can use Pythagoras' theorem to work out BD. So BD is the square root of 112. And then I can use trigonometry to work out CD. I'll label up my sides. I'm trying to find H, and I've got O, so I'm going to use SAW. So sine 40 equals square root of 112 over x. So I need to swap those round. So x equals square root of 112 over sine 40, which means that x is 16.5 centimeters. So CD is 16.5 centimeters. From the red question, I need to work out the size of the angle BCA. So if I look at this triangle here, ABD, label up my sides, and if I'm trying to find the side A for adjacent, that means I'm going to use TOA. Swap tan 43 with x. So x equals 8 over tan 43. Then I look at triangle BDC. So I know that CD is 12, take away the side that I've just found, AD. So CD is 3.42. So now I can work out the angle BCD. So I've got the opposite and I've got the adjacent, which means I'm going to use TOA. So tan BCA is 8 over 3.42. So I do tan to the minus 1, 8 over 3.42, which means that that angle is 66.8 degrees. And now I've completed success criteria 4. So now I've completed the last objective. It's time to end the video. Hope you enjoyed it and hope you found it useful. Make sure to like and subscribe and be sure to check out the videos on the rest of the channel. I'll see you next time. See ya.